evaluate limit x tends to 0, x to the power of x. In order to make the simplification easy, what I do is I'll take this limit as some value y. So y is equals to limit x tends to 0, x to the power of x. And let us apply logarithm on both sides. If I apply logarithm, it will be log y is equals to limit x tends to 0 log x bar x, which can be written as limit x tends to 0 x into logarithm x, since the reason is log a power m equals to m times of log a. Now, if I substitute x as 0, it is 0 into log 0, whereas log 0 is undefined and we cannot use El Hospital rule here. So in order to convert it into 0 by 0, what I do is I'll write this limit as logarithm of x by 1 by x, so that it is in the form of infinity by infinity and infinity. Now we can use this El Hospital rule. So let us differentiate the numerator and denominator separately. Differentiation of log x is 1 by x. Differentiation of 1 by x is minus 1 by x square. So this is nothing but limit x tends to 0 minus of x. Whereas the value of x is 0. If I substitute minus of 0, that is nothing but 0. Hence the option is B.
Next, the diode D has threshold voltage, that is V cut in, is equals to 0.7 volts. This is 0.7. And the forward resistance RF is equals to 20 ohms and ID equals to ID. We have to find out the value of ID. See, this problem can be solved in different ways. One method is we can find a threshold voltage here, that is VTH and RTH, and replacing this network with Thevenin's equivalent circuit, we can solve for ID. One more way is we can apply a KCL here, assuming the diode is on. Okay, so if we apply a KCL at node Vx, if we get ID that is positive, then the diode is in on situation and we are going to know ID, what is the value of ID. That is Vx minus 9 divided by 600, Vx 300, Vx minus 0.7 divided by 120, because the diode contributes 20 ohms resistance in forward condition, so is equals to 0. So if we take 600 as an LCM, so Vx minus 9 plus 2Vx plus 5Vx minus 3.5 is equals to 0. So 8Vx is equals to 12.5. So Vx is nothing but 12.5 divided by 8 ohms. So ID is nothing but Vx minus 0.7 divided by 120, which is, so Vx is nothing but 1.5625 volts. If we substitute here, then we will get it as 7.19 milliamps. Hence option C is correct. We have to find the value of the voltage V across 5 kilo ohms resistor. Here V is nothing but minus 10I2 into 5 kilo ohms. So if we know the I2, then we are going to know the value of the voltage across the 5 kilo ohm resistor. So for that we have to find out I2, that is I1 plus 10I2 is equals to I2. So minus 9I2 is equals to I1. So I1 is nothing but 36 volts divided by 20 kilo ohms. So I2 is nothing but minus I1 divided by 9, which is minus 36 divided by 9 into 20 milliamps, which is 9 4s are 4 5s are. So minus 0.2 milliamps. So V is nothing but minus 10 into minus 0.2 milliamps into 5 kilo ohms. Kilo milli going to get cancel each other into 5. So this minus gets cancelled. That is we will get it as 10 volts. Hence option B is correct. Is the PDF of the random process x of t is. See, we know that the distribution function of x of t is nothing but, see, there are only two levels, 0 or a. So if x is less than 0, x is equal to a, so x is greater than a. There are means x can take two different values. If x is not going to take less than 0 value, hence the probability of x less than 0 is 0. The probability of taking either 0 or a is half. If x, the probability of taking one of these two values is 1. So the density function, probability density function, is nothing but d by dx fx of t x is 1 by 2 . So if we plot the distribution function, it looks like this is x of t, this is fx of t of x. So there are few discontinuities. The one discontinuity is at x equals to 0, whose probability is half, and at a, one more discontinuity whose size is half and attains a probability of 1. Hence, if we differentiate this particular function, we will get density function. The impulses are of size delta of x plus delta of x minus a, because differentiation of these gives impulse at this particular point whose magnitude is 1 by 2. Again, this much amount of discontinuity here, so here also same magnitude because the discontinuity size is half. Hence option A is correct.